Singh, Scientist, Neuroengineering Labs, AIMS, New Delhi. Mr. Rajiv Bajaj, Managing Director, Strategies India. Joining us online will be Dr. U. Chandrasekhar, Chief Research Officer, Cambian Labs and former Technical Director, DRDO. Mr. Erez Benzvi, Vice President of Medical Statistics. I also extend a warm welcome to all the dean of various disciplines, head of institutions, directors, principals, head of departments, staff, my colleague faculty members, and dear students. Technology is both a tool for helping humans and destroying them. This is the paradox of our times which we are compelled to face. This great thought by renowned philosopher Norman Finkelstein is what we are aligning with today. Today's ceremony marks the milestone towards greater and most essential association between cutting-edge technology and academia for the betterment of society. This collaboration between MGM University and our technology partner, Statistics, will strengthen our students for resolving complex real-world problems and create a better world. As per our tradition, we always start our auspicious occasions with lighting a lamp, because light is a symbol of brightness, prosperity, and divinity, which guides us all in all our endeavors. The motto of MGM University is Apo Dipo Bhava, which implies spreading the light of knowledge. So keeping this vision with ahead of us, let us light the lamp to wish the best for occasion. I request honorable dignitaries to please join us in lighting the lamp.
Now I request Department of Music and Theatre and their team for Saraswati Vandana.
धन्यवाद.
Thank you very much. As Dalai Lama once said, the roots of all goodness lie in the soil of appreciation. Today we have with us men of great accolades, and we would love to take this opportunity to felicitate them. So I humbly request Honorable Chancellor MGM University, Shri Ankush Rao Kadam Sir, to welcome and felicitate Honorable Dr. Ramandeep Singh, Scientist, Neuroengineering Labs, AIMS, Delhi. Now I request felicitation of Dr. Dinesh Singh Thakur, Director, Defence Institute of Advanced Technology, Pune. Felicitation of Mr. Rajiv Bajaj, Managing Director, Statistics India. Felicitation of Mr. Rajiv Bajaj, Managing Director, Statistics of India. Thank you, sir. Joining with us online for this event are Dr. U. Chandrasekhar, Chief Research Officer, MGM Labs and former Technical Director, DRDO, and Mr. Erez Benzevi, Vice President for Medical Statistics Israel. So we wish to convey our gratitude to them. Moving forward, now I invite Dean Engineering and Technology, MGM University, Dr. Harirang Shinde, for the introduction of the event.
Honorable Secretary of MGM Trust and Chancellor of MGM University, Sri Ankush Rao Kadam Sir, Professor Dr. Vilas Sapkal, Vice Chancellor, MGM University, Chhatrapati Sambhajinagar, Dr. U. Chandrasekhar, Chief Research Officer, Cambrian Labs, and former Technical Director, DRDO, Bangalore, Mr. Erez Ben, Vice President, Medical Statistics, Israel, Dr. Ramandeep Singh, Scientist D, Neuroengineering Lab, AIMS, Delhi, Dinesh Singh Thakur, Director, DITA, Pune, Mr. Rajiv Bajaj, Managing Director, Statistics, India and Southeast Asia, Dr. Ashish Gadekar, Registrar, MGM University, Dr. Survanshi, Mr. Sudarshan Latkar, CEO, Sigma Pune, all honorable dignitaries of the dais, invitees, deans of faculties, head of the institute and department, faculty, staff, dear students and friends. A very good morning to everyone. On behalf of MGM Trust and MGM University, I welcome you all for today's inauguration ceremony of J850 Digital Anatomy 3D printer being set up as a part of MGM University Innovation, Incubation and Research Center IIRC. MGM University's ambitious Innovation, Incubation and Research Center is one of its kind state-of-art technical excellence center in the Marathwada, with sole objective to promote and inculcate knowledge and skill of advanced technology to meet the demand of the industry. At IIRC, with our esteemed laboratories like collaboration like Sigma, Christiani Sharpline, MSC Software, and many more, we are running interdisciplinary skill-based learning initiative in the field of industrial robotics, industrial automation, mechatronics, drone technology, electrical vehicle, and additive manufacturing. Now to diversify and add more advanced technology portfolios to MGM University Technical Excellence Center, today we are inaugurating newest addition, which is Stratasys J850 Digital Anatomy 3D printer, a cutting-edge polyjet 3D printing technology. The J850 Digital Anatomy printer brings medical model to life with incredible realism that accurately represent both the appearance and response to the human tissue. These models provide unmatched clinical versatility, repeatability, and accuracy for healthcare professionals and medical device companies. As we all know, India carries a great heritage in the development of the technologies and has given the world many revolutionary researchers. These ability of Indians are what gave the world so many successful engineers who are not only running but also leading many global tech giants today. Our youth have great potential to succeed. What is needed is to make the experience of learning more interesting from the early stages. One of the best ways to do this is adopting Gandhian approach to education, that is, learning by doing. Students should be taught engineering through interesting activities and real-world problem solving. They should be encouraged to apply engineering in their everyday life. That is why the Government of India has come up with a National Education Policy, NEP 2020. This policy proposes the revision and revamping of all aspects of education structure and lays particular emphasis on the development of the creative potential of each individual. It is based on the principle that the education must develop not only cognitive capacities, but also social, ethical, and emotional capacities and dispositions. It is my privilege to inform all of you that MGM University is one of the pioneers in implementing NEP 2020 in its academic curriculum from the academic year 2023-24. In addition to this, today's inauguration event will also foster our commitment to integrate advanced technologies into academic curriculum for the benefit of our stakeholders. This is an age of innovation, and if we want to succeed in it, we must embrace the latest technology with all its beauty. It can give us not only the better scientists and engineers, but also more rational and creative industrial individual in every field of life. I once again extend my warm welcome to August gathering. May the great mind present here bring glory to our nation. Thank you.
Thank you, sir. Moving forward, now I invite Honorable Registrar MGM University, Dr. Ashish Gadekar, sir, for a brief on MGM University.
Good morning, everyone. As we gather here for the inauguration of Stratasys Digital Anatomy Printer, latest edition at the Innovation, Incubation and Research Center. We have all the distinguished guests on the dais and off the dais. On behalf of MGM University and on behalf of Honorable Chancellor Honorable Shri Ankush sir and Honorable Vice Chancellor Professor Dr. Vilas sir, I welcome all the distinguished guests on and off the dais as well. Members from the press, all the heads of institutions, not only from MGM but also across Chhatrapati Sambhajinagar, and more importantly, the students of the entire campus, both from engineering as well as medical. Today it's a rare occasion that we have both the students present here. We are extremely happy that we have reached to this stage where we are inaugurating something which is common to across all the platforms, whether it's design, whether it's from the field of medical, from the field of engineering, and also from biotechnology and biosciences. And hence we have such a huge gathering and distinguished gathering as well. The seeds of this multidisciplinary approach were sowed long time ago. Though the institute, the MGM University, was established in the year 2019, as I said, the seeds were sown probably 40 years ago when the Mahatma Gandhi Mission Trust was established with the vision to work in the area of healthcare and education and research. This campus itself was its first campus, which was introduced in the year 1983 in the form of Jawaharlal Nehru Engineering College, and we have deeply anchored to this institution around which all the colleges in the field of engineering and other have been established. In the same time, we have medical college and hospital, which was also established. First medical college and hospital in this area was established in the form of MGM Medical College. Around these, the approach of multidisciplinary was started way before even national education policy was even, the National Education Policy 2020 was envisaged. And hence it was extremely easy, or easy for the institution, for the university to implement this national education policy, with which together we have all the disciplines, even from engineering, they're moving towards the non-engineering sides as well, seamlessly choosing the disciplines. IIRC is the Innovation, Incubation, Research Center, was also formed on the same lines, where we started with Industry 4.0. We, just like Shinde sir mentioned, 3D printing, additive manufacturing, what we called electric vehicle labs as well. And with those labs, we were able to start certificate and programs which were correctly aligned with the new education policy as well. And today marks that occasion where we have all the 5 different faculties. One is engineering and technology, under which we have engineering colleges. Not only that, but we have performing arts, we have social sciences and humanities, we have biotechnology, we have basic sciences, we have design as well. So all these discipline students of across 7,000 students which we have today in this campus are all working together, all getting educated together with this blending approach. Likewise, we have also introduced Center of Excellences, not only in the field of engineering, but also in the field of film, in the field of cyber security as well. These will, I'm sure, in the coming time, will make us get more students to converge in different areas and gain their expertise as well. MGM University is hugely proud of having Stratasys as their partner, not from today, but in the past as well, and because of which we were able to carve this. It wouldn't have been possible without the presence of Sigma as well. We have Sudarshan Latkar, who has also been instrumental in this formation of these alliances for us. Once again, I thank all the dignitaries who have come all the way from, whether it's AIMS or DAIT as well, to be here, and also those dignitaries online, present online across from Israel as well. We are looking forward to listening to them. But from MGM University, we would like to extend our warm welcome any time in the future as well. So thank you very much for giving me this chance, and welcome, and look forward to this event. Thank you.
Thank you, sir. Now I request the technical team to start the demonstration video of IIRC, Innovation, Incubation and Research Center, Phase 1 and Phase 2 labs.
Welcome to the grand opening of our Innovation Incubation Research Center, where ideas flourish and innovation thrives. This center is more than just a facility. It's a hub of creativity and discovery, designed to foster groundbreaking research and development. In Phase 1, the following labs have been set up: Industry 4.0, Industrial Hydraulics and Pneumatics, Industrial Automation, Computer Integrated Manufacturing, and Industrial Robotics. In our Mechatronics and Industry 4.0 lab, we integrate mechanical engineering, electronics, and artificial intelligence, shaping the future of smart manufacturing. Our Industrial Hydraulics and Pneumatics lab, where fluid power systems meet innovation, enhancing industrial efficiency and sustainability. Our Industrial Automation lab is a hub of digital transformation, where automated systems optimize production processes with unparalleled precision. Moving forward, our Computer Integrated Manufacturing lab leverages digital technologies to streamline manufacturing workflows and enhance productivity. Last but not the least, our Industrial Robotics lab pioneers advancements in robotic technologies, enhancing agility and efficiency in industrial settings. Through Phase 1 of IIRC, students benefit from advancements in mechatronics, industrial automation, and beyond, fostering innovation and practical learning opportunities. Welcome to the Phase 2 of our Innovation Incubation Research Center, a testament to our commitment to cutting-edge research and development. In Phase 2, the following labs have been set up: Unmanned Aerial Vehicle Lab, Endres Hauser Lab, Additive Manufacturing and Reverse Engineering Lab, Electric Vehicle Lab, and our Advanced Driver Assistance System Lab. In our Unmanned Aerial Vehicle Lab, we pioneer advancements in drone technology, from aerial surveillance to precision agriculture and beyond. Next, the Endres and Hauser Lab, where precision meets innovation, advancing sensor technologies for industrial automation and process control. The Electric Vehicle Lab is at the forefront of sustainable mobility, developing next-generation electric vehicles and charging infrastructure. Last but not least, our Advanced Driver Assistance System Lab pioneers safety innovations in automotive technology, enhancing road safety and driver experience. At the heart of IIRC Phase 2 is a dedication to pushing the boundaries of technology, transforming industries, and shaping a sustainable future.
Now it's time for the inauguration of Stratasys J850 Digital Anatomy 3D Printer. So I request Honorable Chancellor Ankush Rao Kadam sir and all the dignitaries to join in digital inauguration of the J850 Digital Anatomy 3D Printer.
To the inauguration of state.
Thank you, sir.
Care innovation, patient care, and engineering application. Today marks a significant advancement in our ability to provide personalized medical solutions and enhance surgical precision. With this technology, we can now create precise, patient-specific models that revolutionize surgical planning and medical education. These models will not only improve our understanding of complex procedures, but also empower our healthcare providers with invaluable tools. For patients, it means clearer communication and a deeper understanding of their treatment options. We look forward to the positive impact our digital anatomy 3D printer will have on patient care and medical education. Here's to a future where innovation continues to transform healthcare for the better. IIRC, where ideas take flight and innovation transforms the future. Thank you.
Thank you so much, sir. Today's keynote speaker is joining us online, and I feel privileged to introduce Dr. U. Chandrasekhar. Sir is an aeronautical researcher and academic administrator with extensive insight into experimental mechanics, additive manufacturing, aerogas turbines, and outcome-based education. Sir has worked for DRDO in various capacities for about 28 years, rising to the rank of Additional Director GTRE. He has set up the DRDO's first additive manufacturing laboratory in 1999 and did several projects connected with combat aircraft programs. During years 2013 to 2015, he worked at Institution of Engineers, India as the Director General, followed by a stint in a university as Pro Vice Chancellor. In 2011, he led a DRDO scientist team in engine flight testing at the Central Institution of Aviation Motors, Moscow. Sir has received a gold medal from Dr. APJ Abdul Kalam for his academic achievement at IIT Madras. He serves on the academic subcommittee of National Board of Accreditation and also as the member of AP State Council of Higher Education. Sir has carried out several projects for DST, Royal Academy of Engineering, Wipro 3D and DSIR. Currently, Sir is adjunct faculty in the Center for Product Design and Manufacturing at IIRC and Chief Research Officer for Cambridge Innovation Center at Bangalore. With this brief introduction, I request for the keynote address.
Good morning.
Good morning, sir. You are visible and audible as well.
Okay. Thank you so much. And I just wanted a confirmation whether my screen is also visible.
Yes, sir, it is visible.
Okay. At the outset, I would like to congratulate the fraternity of MGM University, Stratasys, and Alton on this great initiative of starting a 3D printing technology-centric facility. In the recent times, we have clearly seen the impact of digitization on almost all the sectors in the country, starting from aeronautics to healthcare. And the impact of digitization on the manufacturing has manifested in terms of 3D printing, becoming as a catalyst for many product development initiatives. 3D printing, in its nascent evolving stage, was considered as an extension of manufacturing. But now, if you look at the profile of 3D printing, it is so very multidisciplinary. It's become an interplay and a confluence of several disciplines, including physics, polymer chemistry, material science, control engineering, software systems, and most importantly, design. And the applications of 3D printing are quite enormous and they keep expanding. What started as a technology which was primarily supported by aeronautical and automotive companies has now become a ubiquitous feature, so much so that every product development in digitally sensitive company today employs 3D printing right from product development stage up to the batch production. And one of the parameters which has enabled this particular phenomena is the variety in materials. We have polymers, metals, composites, waxes, ceramics, bimetals, functionally graded materials, and the synergistic combination between the variety of materials and the processes is the reason why now 3D printing has become a force to reckon with. The material choices today, if you quickly glance, you have resins, which are generally associated with stereolithography, and you have got versatile materials like ABS, PLA, Ultem, polyether ether ketone, PEEK, which is biocompatible, connected with FDM ecosystem. And you have plethora of choices when it comes to metal printing, including superalloys, aluminiums, titanium alloys, refractory materials, which can work with at a very high temperature. I had an opportunity and privilege of working very closely with this technology since 1999, wherein I got to set up the first 3D printing lab in the defense ecosystem in close conjunction with the Stratasys, 3D Systems, and EOS. Subsequent to that, I had opportunity to continue with the research aspects of this technology in IIT Bombay, where I worked as a professor, CPDM, where I'm currently associated in the Indian Institute of Science. And during my stint at Wipro 3D, I had an opportunity to carry out multiple projects for ISRO, VSSC, Airbus, Boeing, Honeywell, Shell, etc. In today's talk of about 15 minutes, I would like to capture some of the essential features of these efforts. Example, you can look at 2014 project, which we carried out under the aegis of Department of Science and Technology under Indo-Taiwan. The entire focus was on developing this unibody, monolithic drones, which can be flown over the railway bridges, and we can get the information through real-time processing on the onset of cracks. So the 3D printing in this case was an enabler of developing a system which can directly be put into the practice, which in this case happens to be the structural health monitoring of heritage structures and railway bridges. I would like to spend definitely 60 seconds on this slide. Many young students who have assembled in the hall can get inspiration from the achievement of Agnikul Cosmos, started by 25 plus age people. And very recently, they became the first ever company in the entire world to print a rocket engine and successfully test. And if the students can note the innovation extent in this particular achievement is as good or as impactful as what you can see in the multi-million spaces project of Elon Musk, which is known across the world. So I would like to say that 3D printing and technologies which are part of the digital transformation have brought in democratization in the innovation ecosystem, and hence, and due to that, the student teams from places like Pune or Aurangabad or Chennai or Noida or Gurgaon can compete with the world's best in producing physical artifacts that can provide functional applications. And immediate question you would like to ask me is, how can we be very sure that we are using the technologies properly and fulfilling the needs of the end users? So luckily now we have got standards from the companies, from the organizations like ISO, ASTM, AMS, SAE, etc., which talk about what are the best practices, what are the quality-oriented practices corresponding to processes, corresponding to the applications, and corresponding to the materials. And I would like to say that the UGC has taken bold steps in terms of creating a National Credit Framework, NCRF, as it is called. And the proactive universities like MGM can start today practice-based or activity-based orientation or courses, and they can provide the credit equivalence between the general courses and these practice-oriented or skill-oriented courses. And if you have seen in the some of the latest episodes of Shark Tank India, you have seen young engineers coming from small places who are talking about bringing revolutionary changes in the healthcare and fashion sector by using 3D printing for the product development. And one important thing which might be really be useful to the faculty members is there are templates now which are available under Ministry of Electronics and NILIT, through which you can give digital certification to the qualified students, which are recognized in about 60 plus countries in terms of authenticating the skill and proficiency of a student, could be even a first year student, on what he can do. I would like to spend about a minute in talking about what is the research trend. We all know that if the material has got low density, its strength is low. If the material has got high density, the strength happens to be high. Now, the concern is, how do I make the structures which are light in weight but very strong in their performance, like what you see in this platform? And this is where 3D printing is enabling the engineers and the researchers for diverse backgrounds, including physics, thermodynamics, chemical engineering, and computer science, in terms of developing these lattice structures and introducing them for superior heat transfer in extremely important cases like data centers, which are going to cause about 4% of the global electricity consumption. You can see a connect between what this technology is able to offer as a design innovation with the data centers. I'm showing now one of the first ever student teams which worked with me from mechanical engineering in 2012. And in this case, we are looking at developing custom-made prosthetics for tumor-affected pelvic girdle. You can see here a 1:1 replica of the pelvic girdle, which we made using FDM, and different iterations of the implant, and a finite element analysis of the implant, and finally, the experimental mechanics or experimental stress analysis of the implant configuration, a full-scale replica under the simulated loading conditions, which is able to give the information to the physicians in terms of where exactly is the stress concentration on this particular implant configuration in case you convert into the real implant. So there are plentiful of applications today which are awe-inspiring, from aeronautics to automotive to electronics to consumer goods to healthcare to pharma to space systems, and also post-service life in terms of extending the life for repair and refurbishment. About 5, 6, 7 years ago, along with Mr. Rajiv, I had an opportunity to meet the CEO of Niti Aayog, Mr. Amitabh Kant, and he doesn't require any introduction to the audience today. And when he published a book, which you see here as an enclosure in this particular slide, he talked significantly about how you can use the digital manufacturing technologies not only for enabling our manufacturing sector, but also for reimagining the education and skilling in India as we are moving towards Make in India like ecosystem. Recently, the Minister of Electronics has come out with a national strategy for additive manufacturing, which talks about usage of the technology for multiple sectors, and which talks about evolution of the technologies in the ecosystem. And one of the manifestations of this particular effort you can see in Idea Labs. It's a possibility that MGM might be having already the makerspace. Currently, the makerspaces are getting connected with the local networks, and then slowly and steadily, but definitively, they are becoming part of the global networks, which can be seen in this enable kind of a network. What is the enable network? It's a digital connectivity among 50,000 odd volunteers from across the world. And in those situations wherein some children lose upper limbs because of the calamities or the wars or the bombs or terrorist activities, these volunteers get connected with each other. Could be an orthopedic surgeon along with an engineer from Aurangabad, with some physiotherapists from Mumbai, and digitally they connect and develop these implants and help the handicapped persons in terms of achieving their life back completely free of cost. I have been carrying out the Royal Academy of Engineering program in association with VIT Vellore and Mapua University, wherein the focus is how exactly we can incorporate these technologies while we are ensuring the safety. I welcome the members from MGM University also to join the cohort and sensitize our students and faculty members on the safety aspects connected with 3D printing. I'll just pick up one example and then conclude my talk. Drones don't require any introduction to the current generation, and drones come in different ways. And one of the manifestations of drone is an ornithopter, which is a bird mimicking micro-aerial vehicle. So you can see here how 3D printing can be used, let's say by the students from the first semester, to convert the rotary motion into the flapping motion of the wings and realize the ornithopters in less than 2 days' time. No wonder now there are many instances, including the one which is known all over the world from BMW, which has set up the additive manufacturing campuses with about 50 plus systems with very less manpower, so that they can create one of its kind parts as well as the spare parts for the legacy systems and help the customers. And the last part of my presentation is about giving a message to the students on what is that they can do. See, the people who, luckily I had an opportunity to meet with all these young, vibrant innovators, Firoza Puthari, Ayush Bagla from PS University, Siddhant Pai from Pune. And what Siddhant Pai has done is he created an ecosystem wherein the waste plastics from rag pickers can be converted into 3D printing filaments with distributed manufacturing model, and the rag pickers in turn can create these affordable toys through recycling of the filaments. And this is the instance of a biotechnology student called Firoza Puthari from Mumbai, who went on to set up a company called Unatomized 3D, wherein the focus is on creating the surgical models directly by transforming the X-ray and CT data into 3D CAD model. Most of the programs today in the country follow the National Board of Accreditation outcome orientation the protocol. So the initial focus is on remembering and understanding, and gradually we expect the students to apply the knowledge, and finally we expect the student to create something. But 3D printing, when it is introduced in the foundational semesters, empowers the students to directly create and transform their ideas into physical artifacts. And if you go to institutions like IIT Hyderabad or BITS Pilani, you can see that the first year engineering graphing course is substituted with a digital fabrication course, and thousands of products are made by the students while they are in the very first year of their engineering. So there are a lot of inspiring instances of this kind, wherein young engineers, young students are pitching in their ideas from conceptual stages to the advanced stages, and the Government of India, through multiple ministries, supports these initiatives through funding ranging from about 2 lakhs to 1 crore for becoming a successful entrepreneur. I had an opportunity to design and develop a system connected with 3D printing of the ceramics, and this was supported by DST AMT call in 2012. And I just want to say that we introduced small, affordable digital cameras to pick up the data from each layer, and then the students from the computer science with the machine learning background were able to develop the predictive algorithms for identifying the onset of defects. So the UGC currently has placed enormous emphasis on connectivity between the universities and industries. And whatever today is being seen in MGM and association with the statuses is a step in the right direction in terms of connecting with the industries and developing the templates for academics and forceful research. You might have seen that under National Research Foundation, close to 15,000 crores has been committed for supporting the activities of the organizations. And especially when you're talking about metal 3D printing, wherein the effects can be seen at the macro, meso, or micro level, there is a continuous thrust in terms of connecting the process parameters and the structure and properties. And the more important is the application, the more crucial is the application. The emphasis on testing the components under the simulated loaded conditions becomes more important. So I wish the fraternity of MGM all the very best in picking up this technology from its application status and slowly and steadily marching towards the greater objectives of serving the nation by making critical parts for several sectors, including aeronautics, healthcare, and defense. Thank you so much for this great opportunity. And I wish this cohort to be extremely successful in creating an impact on the ecosystem. Thank you so much.
Thank you so much, sir. Thank you so much for your valuable time and your valuable inputs. Definitely, this will be very helpful for our students. I have from the audience, if any questions for Dr. U. Chandrasekhar. Sir, we have some questions from the audience for you.
Yeah. Maybe you can read out the question. I can hear you clearly.
Yes, sir. Sir, there's one question from the dais. Vice Chancellor, Professor Dr. Vilas Sapka. Sir is saying that, is it possible for reusable material in the same technology?
Yeah. I would like to tell the Vice Chancellor that yes, reusing and bringing in sustainability into the 3D printing is an active research domain. And in fact, DST in the previous call also allocated the funding for a couple of projects that talked about recycling the metallic waste and putting into the service in terms of connecting with the metal prototyping system. I think IIRC is currently involved in this particular activity.
Thank you so much, sir.
So there's one more question.
Yeah.
Yeah, please, ma'am.
Yeah. Good morning, sir. Thank you for the talk. I have a question. I am a faculty of biotechnology, and looking at the advancement of 3D printing in the organ development, how do you see the future implants? Is it possible that we could be able to have the cell culture technology and build the models, the 3D models, and may use it for the transplantation? What are your views on this?
Yeah. Actually, you've got an AIMS expert who will be talking to you, but I'll quickly say the applications of 3D printing for cranial implants, orthopedic implants, maxillofacial implants, dental applications, including the crowns and bridges, are some things which have been systematically explored by several practitioners across the country. And especially when it comes to dental practices, you see these Invisaligners in more than 50% of the instances. And if you're talking about tissue engineering using 3D printing, it's also coming up. The research group from Shastra University is into the development of artificial skin using 3D printing, especially for treating the burn victims. And there are also a few research activities which are happening under the aegis of Department of Biotechnology under a program called BIG, wherein the focus is on implantable devices, including the drug delivery systems using 3D printing as the enabler. So many things are happening, but I just want to emphasize that whenever you are talking about medical applications, realization of the part or implant is not a challenge, but ensuring that it is biocompatible and ensuring that it conforms to all the expectations of AA or equivalent bodies in the country becomes more time consuming, and hence the focus has to be on that part.
Thank you so much, sir.
Sir, I have a question, sir.
Yes, please.
So I am a faculty of mechanical engineering, sir. The session was very nice, but I would like to know the recent trends that are available in silicon liquid printing.
Okay. Yeah. Since Mr. Rajiv Bajaj is going to talk about advancements in the technology, I will not dwell in detail, but I just want to say that whether you are talking about epoxy resins or silicons or molten waxes, it's only the rheology of the material which is very important. So you talk about viscosity and the impact of temperature on the viscosity, and you can create these extrusion systems or syringe-like systems for delivering the materials. Definitely, there are commercial systems currently available to tackle viscoelastic materials, including the silicon rubbers. And this has become extremely prominent during the COVID time when people were talking about developing the silicon rubber parts for medical devices.
Thank you so much, sir. Thank you so much for summarizing all these technologies in a simpler way. Thank you for your time.
Thank you. So With your permission, I would like to close my presentation now. Thank you so much.
Thank you. Now it's time to understand the Stratasys technologies better. So I would like to introduce our next speaker, Mr. Rajiv Bajaj. Mr. Rajiv Bajaj is Managing Director, Stratasys India and Southeast Asia, with over 20 years of experience in technological industry. Sir leads Stratasys India and SEA team for last 7+ years to drive sustainable growth of additive manufacturing in the region. Sir has extensive experience in manufacturing industry in driving business transformation and has been a speaker in leading industry forums like CII, ACMA, and IMTMA on driving innovation through technology adoption in aerospace, automotive, and consumer goods industry. Prior to this, Rajiv was the country manager at Autodesk India and SARC, heading the manufacturing solution business unit and managing the growth strategy across different industry segments. Sir has also held the positions with leading product lifecycle management companies, including Dassault Systems and PTC, playing an instrumental role in sales and channel management. So with this brief introduction, I request Mr. Rajiv Bajaj to enlighten the audience with Stratasys 3D printing technology and its future.
Good morning, everyone. Good morning, everyone. I'll just log into my system and start the presentation. But in the meanwhile, I would like to thank Dr. Yusi for a wonderful keynote presentation. It sets the ground for dwelling deeper into what 3D printing can do and what are the possibilities that students like you can explore and push the boundaries of innovation with. Today, I'm going to talk more about the adoption of 3D printing because we have experts who are going to talk more on the technology side. So I'm going to look more on the implementation side of the technology. Just give me a second, please. As you can see, there are 11 stars in my password, and it is easy to crack. All right, so can I have this, please? Thanks. So I'll give you a very brief overview on the company Stratasys, what we are, what we do, and then start with customer examples on how this technology is here and now and not something which is space age further down into the future. And I, at the outset itself, congratulate MGM management team for having adopted this technology a few years ago and now augmenting it with the latest trends that exist in the industry. So Stratasys is the global leader in 3D printing, and our mission statement is very simple, that we wish to be the first choice polymer 3D printing provider at every stage of life cycle of product development, be it design, manufacturing, or healthcare. So with that intent, we are always innovating and leading the world towards pushing the boundaries of innovation in every sector of manufacturing. So with the size of $650 million, we are a global company, having established our office in India about 20 years ago. And we have a wide network of our channel partners who are serving our customers close to the point of use. Leading organizations like Boeing, General Motors globally, and more locally, Maruti Suzuki's, Hero MotoCorp of the world, MGM University, All India Institute of Medical Sciences, Mahindra & Mahindra, Ashok Leyland, take the name, almost every customer is using our technology in full force. So let's look at what's happening with India right now. And where are we in terms of our global initiatives? Where do we rank with healthcare initiatives? And what is the status quo? So today, we are the 5th largest economy with $3.94 trillion. Can someone tell me who did we overtake recently to become the 5th largest economy? Students, who did we overtake recently to become the 5th largest economy globally? UK, all right? And possibly we will become the 4th, 3rd very soon as per the predictions, and Viksit Bharat by 2047 as our Honorable PM says. More importantly, the Indian healthcare market, which was valued at about $110 billion in 2016, is now projected to reach $638 billion by 2025. That's more than 6 times the growth. Healthcare adoption is increasing. Medical tourism is also boosting this growth. Affordable healthcare, government schemes, all of this is pushing the medical business. Also, medical device development is a part of it. We are now also the 3rd largest automotive market in the world. Can someone tell me who did we overtake to become the 3rd? Guesses also, no negative marking in your questions, okay? Who did we overtake? Japan. Awesome. So Japan, we overtook Japan to become the 3rd largest automotive market in the world. So there's progress all around us, all right? But some things to also worry about, that R&D investments as a percentage share of GDP is not very high. We stand at less than 0.7%. Now, if we compare it with some of the leading geographies, Israel is 4.6%, South Korea 4.5%, China is 2.1%, US also is high. So that also kind of is an indicator of how innovatively we are producing or manufacturing our products and where do our products matter in the world. Why is it that we do not see so many Indian products on a global scale? Why is it that we do not even see software products on a global scale? We are still a highly services-based economy, and this is something which I think students like you can change by adopting more product-oriented approach. And when I say product, it could be a software, it could be hardware, it could be a medical device, it could be anything that can change the way we live and make our lives better and be globally successful. Also, India ranked 40th out of 132 economies in the Global Innovation Index. And we were actually way down a few years ago. We have now crawled our way up to this position. And I think investments into technology, something that's already working in other parts of the world, learning from them and bettering it will make us come to the top 10 in the near future. And also our healthcare position is not very good. We ranked 66th out of 195 countries in the Global Healthcare Security Index, something that we need to collectively improve. So that's where we are. Some good nuggets, some not so good, but adoption of 3D printing, I think, has taken a leap overall in the country. And today what I'm going to share with you is not from what Mercedes-Benz is doing in Germany, what NASA is doing in the US. It's all here and now, what our Indian customers are doing with this technology. Before that, one last point. Even the government realized that Jugaad innovation will not serve our way to become the 3rd largest economy in the world. And we need to innovate and become faster and better. So this was an economic survey from 2021, but I still hold it important because we need to think out of Jugaad innovation. We need to think that, we have to be creative. It's okay to spend money on technology, but you should be faster to innovate. So now let's look at what some of our esteemed customers like MGM are doing with our technology. My last question of the day. Can you tell me where is Mr. Gates standing? Sorry? Okay, Statue of Unity, I think most people know it. So he was here for a brief trip to India and he visited the Statue of Unity. Can I have the audio, please? So this is our great Sardar Vallabhbhai Patel. What did he do? He actually was instrumental in getting 526 princely estates combined into the Great Republic of India. By the way, he also had the Great Chai, which also I am also very fond of. So the Statue of Unity that we see here is actually twice the size of Statue of Liberty. It's at about, if I read it, 182 meters, and the Statue of Liberty is at about 93. So the tallest statue in the world, how do we make it? And why am I presenting it in a 3D printing forum? So what you see on the screen now is about a 4-foot replica of this entire statue along with the cladding. Cladding means the adjacent boundaries that was built along with it. And you would see a lot of black spots if you observe closely. And these black spots are the places where sensors were put, and this was put in a wind tunnel. A wind tunnel testing is normally required for buildings that are that high to look at any eventualities in case of a high wind, earthquake, any other natural calamity. So a company called RWDI in Trivandrum on South India, they built this. They did 140 tests in their wind tunnel to certify this statue for its structural integrity, and post that it was built. And how 3D printing helped them was really fast-track the entire process, test up to wind loads of 40 meters per second, and give very reliable and accurate results for erection of this statue. And of course, we are in a medical institute. We all know God is our creator and source of life, but life is also very vulnerable. Diseases happen, things happen, accidents do occur, and we have to be prepared. So this example I'm taking from All India Institute of Medical Sciences. What you see on the screen is multiple kidneys with different levels of tumors that they have, and surgical. I'm not a doctor, so if I go wrong, please correct me somewhere. A surgery called partial nephrectomy was done on these. And now it's very essential for the surgeon to preserve as much of the healthy kidney as he or she can and make sure that the patient has a higher life expectancy. Now, if you see these files in 2D with Diacom or other scans that they have done, and then a radiologist explains to a surgeon, a part of it may get lost in translation, and sometimes when you open up the patient, there could be some surprises that the surgeon was not expecting, leading to either a higher surgery time or a not so good surgery, etc., and decrease in patient's life expectancy. But with 3D printing, you can actually hold the part, and the beauty of digital anatomy printer is that the tissue structure that it gives, the tissue field that it gives is very similar to the human tissue, and the surgeon can actually practice the surgery much before the actual surgery is conducted. And how much time will it take to make some kidney like this? Maybe 3 to 4 hours post the scans are done. So these have been very successful in giving patients a higher life and a better life expectancy post-surgery, and also, of course, much reduced surgical timing. And Dr. Amandeep will talk more about such cases today. Also, 3D printing has been very, very popular in aerospace and automotive industry for a very long time. And one of the earlier companies to adopt this in India on the shop floor was a company called Honda, where the chief operating officer is an alumni of MGM Engineering Institute, a person by the name Naved Talib. And we worked very closely on this project with him. So for those of you who have an engineering background would understand jigs and fixtures and the role that they play on the shop floor. So quickly I'll explain. The pictures on the top, they were the traditional tools that they were using for measuring the car gaps for the windshield when they were being placed on the car. And any gaps or errors would result in breaking of this windshield a little later in the quality checks, and a very expensive replacement process. And what we helped Honda with, we collaborated with them and brought out these much lighter parts that you see on the bottom of the screen. We replaced metal by plastics, and these parts are being used still on the shop floor at Honda. And if you see the whole car as it looks today is like this. And Mr. Talib, who I said is MGM pass out, he was actually very instrumental in helping us adopt this technology and collaborate with us, is that quality and consistency is redefined and they get it first time right always. These parts are almost 70% cheaper than the metal parts, and also 80 to 90% lighter. And since we are focusing today on medical with J850 DAP launch at your center, I will talk a little bit more. I will leave with the rest for the experts that are going to talk later in the day, with some examples of how we are transforming lives with J850 printer and other Stratasys technology for the patients in the country. So this one is an example of scoliosis. Most of you would understand. So this patient actually was treated at an institution called Akash Healthcare in New Delhi. by a surgeon named Dr. Ashish Chaudhary, who happens to be the owner of the hospital as well. So there was stage 1 deformity correction with soft tissue release, and stage 2 with neuro monitoring was done with the scans. And what was done was a complete spine was built using 3D printing, and where 3D printing played a major role was designing the fixtures and jigs for this surgery. Why? Because the tool or the surgical instrument should not touch any nerve which is not required to be touched during the surgery. So if you see some transparent looking parts on the bone, on the spine, those are the ones that were built using the 3D printer. The bone is also used, the spine is also built using the 3D printer. The fixtures are also used with the 3D printer. And in the actual surgery, this is the actual surgery picture. And you can see the tools being placed at the right positions for the surgeon to successfully conduct the surgery and come up with the outcome that is desired. This is the post-surgery outcome. From a very steep angle, they could make the spine almost straight. So this was done using Stratasys technology very recently in Delhi. And another example is from northeast part of the country, where access to healthcare is very limited, not enough doctors, not enough medical facilities and hospitals. So we did this project along with our partner Altem and a local company which works with the Assam government. And you see two children here, one young girl who lost both her legs to fire, and the other person who lost his leg to an accident. Now this is the process of creating 3D printed parts for feet. So you see this little girl, the entire feet was scanned. And using our other technology, which is fused deposition modeling, an artificial leg was prepared for her. And the smile on her face after she is able to walk for the first time really makes our day and serves the purpose of all of us why we are into this 3D printing space. So this was done very recently, and there are multiple such other cases that we have done in the country. And Dr. Ramandeep will talk more about it, and later my colleague Erez from Israel will also be taking you in detail with some of these applications. So a little bit on the last slide about us. We are a global company with 30 years of experience with the pioneers in 3D printing industry. We have industry-ready solutions that are now being implemented at MGM University right here, and our local expertise and support, which is very crucial to making these technologies successful, because there's a lot of domain knowledge, expertise, experiences, some past learnings that are to be incorporated in the functions that you do here. So with that, I would like to thank MGM management team for inviting me today here and making this implementation work at your university, and the entire leadership team under Baburao sir, and the learning management team, Dr. Ashish, Dr. Vilas, and Dr. Shinde. Thank you very much.
Thank you, sir. This is really a very informative session with so many examples. Now I am delighted to introduce Dr. Ramandeep Singh. Sir holds a PhD with distinction in biomedical engineering from the prestigious Indian Institute of Technology, IIT Delhi, currently serving as a scientist at the Neuroengineering Labs, AIMS, New Delhi. Sir research primarily focus on neurosurgical simulations and the development of innovative instruments for minimizing invasive surgery. Sir possesses deep expertise in medical image segmentation, computer-aided design, and 3D printing. With a keen interest in patient-specific implants, Sir has successfully completed several projects as a principal investigator and co-investigator. His contribution to the field have been recognized with numerous awards, including the Pfizer IIT Delhi Innovation Award, the Modi Prix Gallian Indian Award, and the AIMS Research Excellence Award. With a prolific academic background, Sir has authored 23 research papers in peer-reviewed journal and 15 papers in international conference proceedings. His innovative work has led to the granting of 6 patents with another 6 patents currently in the application process. 2 of the technologies developed by him have been transferred to the industry. Currently, he is dedicated to advancing the field through the development of physical simulation models for training in minimally invasive neurosurgical procedures. Additionally, he actively participates in projects aimed at objectively evaluating surgical skills using sensor or computer vision, as well as the development of robotic instrumentation. With this brief introduction, I call upon Dr. Ramandeep Singh to talk about revolutionizing healthcare harnessing and synergy for Industry 4.0.
So first of all, I would like to thank you, the management of MGM, for inviting me here. It's really an honor. And I would also like to congratulate on the installation of digital anatomy printer. So today I will be discussing our work which is related to advancements in neurosurgical simulation and instrumentation using 3D printing. So our lab, Neurosurgery Education and Training School, it is a DST, DBT and DHF funded lab where the primary focus is to train surgeons, not only from neurosurgery but from other surgical branches. So our lab have successful international collaborations like the Indo-German collaboration, under which we conducted 16 workshops and 231 delegates were trained. Then Indo-US collaboration, the Japan-India collaboration. So our lab has a global reach, and we have trained surgeons from different countries across 4 continents. And till 2023, we have conducted more than 15,000 training sessions in our lab. So the research work in our lab is focused around surgical education, surgical training, surgical skills evaluation, surgical planning, and development of the instrumentation. And we use different technologies for these objectives. We use the CT MRI data, the segmentation, computer-aided designing, 3D printing, embedded systems, then virtual reality, haptics, graphics. Then we work on the vision-based skills evaluation, sensors for the skills evaluation, and artificial intelligence. So we are using 3 different types of 3D printing technologies in our lab. The first one is fused diffusion modeling, in which there is a filament which is melted by the heater, and by layer deposition, we create the different models. Then we are using the polyjet 3D printing, which is the liquid-based material is there, and which is cured using a UV light. And we also use selective laser sintering, in which powder material is there, and it is fused by a laser, and which is basically for the metal parts. And our lab is equipped with different facilities like the CAD software, Siemens NX Unigraphics. For segmentation, we use SimpleWare Scan IP. Then for the finite element analysis, we use ANSYS. We have a JAIS blue light scanner. We have 3 different 3D printers. The Stratasys Dimensionalite, Stratasys Connex, and the Stratasys Digital Anatomy Printer. And we also have Delsys wireless sensors. So a brief introduction about the neurosurgery. So neurosurgery basically relates to the treatment of disorders that are including the brain, spinal cord, and the peripheral nerves. So traditionally, as you can see from the first image, they were based on the open approach, in which the surgeries were done naked eyes or using the magnification loops, and there was direct access to the surgical site. However, there were larger incisions and more complications in these procedures. The next came the concept of microneurosurgery, in which a operating microscope with high magnification and stereo vision is used. That means they have a depth perception. And more recently, the concept of neuroendoscopy was introduced, in which the image is transmitted to a monitor and a camera is inserted inside the brain to get a view of the surgical site. So these procedures are very complex procedures where margin of error is very low, and the technological advancement in optics had led to constrained operative field. So therefore, the iatrogenic errors, which are the errors which are made during the surgery, have drawn increasing attention to the surgical field. And hence, there is a need for advanced training and augmentation of the existing instruments. So coming to the first area, that is surgical education. So we use the CT and MRI data of patients. So CT is good for segmentation of the bony structures, as you can see from the first image. And MRI provides a good soft tissue contrast. So we require same patient CT and MRI data so that we can segment all these different structures. And this is the process of medical image segmentation, in which we have to basically extract the region of interest based on the different surgical approaches. So in the first image, we have segmented a skull, and in the second, we have segmented a brain. And we also conducted a study on the effect of segmentation threshold. So basically, we have to use different threshold values to segment the structures. And in this study, we found that if we use the default values, so there are incomplete production of the bone models. As you can see in the first skull, you can see the nasal part is missing. So the thin bones, they are not coming in the 3D model. So we have to create different threshold values, and we saw that where we are getting the complete skull model. However, as we keep on increasing the threshold values, you can see there is a deviation. In the last one, the J image, you can see it is deviated from the original image. So there is a trade-off between creating the complete skull model and creating the accurate model. And this work we published in the World Neurosurgery Journal, and it also reviewed the AIMS Excellence Award in the year 2022. And using this segmentation, we create this type of models like the scalp, skull, brain, the occipital bone, sphenoid bone, temporal bone. And these are the 3D views of some of these models. So this is same patient's data, CT and MRI, from which we can create all these structures. And we, of course, 3D print these models for the surgical education, where residents get these models issued for their different needs, and they return to the lab after using them. These are some other models using soft tissue. As you can see, this is the fourth one is a COVID lung, in which the left side is showing the infection, and right side is showing how a healthy lung should be. Some other 3D printed models. And during the COVID, since we have segmented all these models, so during COVID, we get an idea that why not create 3D surgical education videos for the residents, since the training was not happening at that time. And using all these models, we created various surgical animations. One of that I will show. So this is a procedure known as endoscopy third ventriculostomy. So in which a burr hole is made on the skull, and endoscope is inserted through the brain, and there is a blockage in the brain which has to be opened. So this is a C-shaped cut. Then the bone is drilled. So these are minimally invasive procedures. They require very small holes instead of the traditional procedure in which the large incisions are required. So the endoscope is inserted, and then there are working channels inside this endoscope through which we insert the instrumentation, like the scissors or the dilators or the graspers. And once they reach that particular location, and we can access these instruments. So this is inside the third ventricle in the brain, where CSF is there, and this CSF is not getting circulated outside. So we have to create an opening in the floor of third ventricle so that this can be absorbed. So generally, the patients which are suffering from this condition, their head swells due to accumulation of the CSF fluid. So this is the instrument being inserted, and this a small cut is made on the membrane. And this is dilated using an instrument known as Fogarty balloon. So once this cut is dilated, the CSF will be absorbed. So these type of surgical education videos we created during the COVID time, and they are freely accessible on our website. Anybody can see those. Yes, next. Now, surgical education we can conduct using these type of 3D videos. But when we come to the surgical training, it requires actual hands-on training, because by viewing, they cannot learn. So traditionally, how surgeons were being taught, so it was based on the apprenticeship model, in which there is an expert surgeon who is doing the surgery, and there is a trainee surgeon who is assisting him in the surgery, and by looking him, he is slowly learning the processes. However, when these modern minimally invasive procedures came into picture, this type of apprenticeship model is no more applicable. So now we need training in the lab for the surgeons so that they can attain a particular level of proficiency before going to the operating room. Otherwise, there are concerns like patient's safety. So what are the methods of training outside the operating room in the lab? So first is to use cadavers and live animal models. So the cadavers, they provide high fidelity and they are very good for training. However, there is a scarcity. So we don't have much cadaver that we can give to every surgical training to use. And same is using the animal models. So there are legal and ethical complications, and they require a dedicated animal facility. The next method is a virtual reality simulator. So there are two companies which are giving commercial products. One is the Immersive Touch and NeuroTouch. So these two companies provide the virtual reality simulator in which they are virtual models on which surgeons can practice the different surgical procedures. However, one of the biggest drawback of using this is that they are giving indirect haptic sensation. So the real instrumentation are not being used. They are haptic devices which are giving the force feedback. So they are getting a good knowledge of the complete procedure, but they don't get the real feel of the tissues. And the third method is to use physical simulator, which we are working in our lab mostly. So these simulators are ideal for providing training since they are inexpensive, accessible, and they provide training in a controlled environment. So we have divided our training modules into three categories. One is the microscopic simulation, that is based on the operating microscope. So first of all, we created synthetic scalp and dura surrogates in which surgeons can practice the suturing. So we created different grades of the surrogates, and 23 neurosurgeons validated these samples and performed the microsuturing task. And the best performing samples were further characterized mechanically using the Shore hardness testing and dynamic nanoindentation. So we have standardized this procedure, and the work was published in a journal. So next we created 3D printed blood vessels using this digital anatomy printer. So again we created different variants. Surgeons practiced on those, performed the anastomosis, and the best performing sample is routinely being used for conducting the training. And we also use simulated blood is pumped in the arteries while doing the training. And this is a microvascular bypass simulator. So in this procedure, there is a blockage in the brain, and the simulator is designed using CT MRI data of a patient. And the training procedure involves using the STA as a bypass graft around the MCA. And so they take that graft and they suture it and they make the normal blood flow possible. The next is the high-speed drilling simulation. So the surgeons use high-speed drills which are running at 80,000 RPM per minute, and they have to do different craniotomies. So that is basically creating a flap to access the brain. So we have standardized this training also, and we have created this stencil, which we have patented this stencil and the training method, in which they have to create 4 burr holes, 4 straight lines, and 2 diagonal lines. And additionally, we were giving training on the sheep scapula and sheep heads, but with the introduction of this digital anatomy, we have created a simulator also, and we have created different parameters like what is a good drilling. There should be circular movements for the burr holes, appropriate pressure, adequate irrigation should be there, otherwise heating will be there. So this is the procedure in which the defined sequence is there for the training. They have to make these burr holes and then diagonal lines, straight lines, etc. And this is on a sheep bone. So initially there was no 3D printing technology which was giving material that can be used to make the bone models for training, because it requires a particular haptic sensation and bone dust should be there. So if you use other methods like the FDM, which is traditionally there, we don't get that feeling. But using this DAP, we get that good feeling. The 4 burr holes have been created, then these are the straight lines they are creating. After creating the 4 the straight lines, they make 2 diagonal lines, and then they can take the flap off. And this is a craniotomy simulator and for this drilling procedure, in which we again took the CT scan data of a patient, then we 3D printed the scalp, and we have created these 2 flaps. So by using this simulator, we can create any anatomy. And as you can see in the image, on the left side, the activity is done by a novice. So you can see how he has made the lines. They are not straight. Even the burr holes are going out. And on the right side image, you can see this is an expert surgeon. So they have to practice from left to, they have to reach that level so that we can say that they have attained a particular level of surgical skills for the drilling. And this study was published in the Bioengineering Journal. Now coming to the neuroendoscopy simulation. So this is the most difficult part, since what happens in endoscopy, there is no depth perception. So they are viewing on a 2D screen and they are operating in a 3D area. So the depth perception is lost. And so this is the first simulator that we created for the basic psychomotor skills training. So for this model, we have received the Indian patent and US patent and Japan patent also. So in this, they have to pick and place these rings, and they have to insert the endoscope and instrument through the small hole that is at the front of the box trainer. And they have to use different type of endoscopes. So there are different endoscopes like 0 degree, 30 degree, 45 degree, which is to give the lateral view. And we can rotate this activity plate using the keypad on the front, and they can practice. So again, we have defined certain parameters, so giving them the score that how well they are doing. So this defined pattern is there in which they have to move the rings. The horizontal movements are there, then the diagonal movements are there, then the plate is tilted at an angle, which further increases the difficulty of the surgery. And the neuroendoscopy involves good eye-hand coordination, the grasping accurately, grasping with appropriate pressure, and not hitting the board behind, and not pulling the rings. So you can see this is a good expert surgeon doing the activity. You can see that he is properly picking the rings. So it looks very easy in seeing, but when you actually do it, this is very difficult because depth perception is not there. This smooth movement is there. He is not hitting any structures. The dexterity is fine. And now you can see how a trainee is doing. He is making shaky movements, hitting the activity plate, hitting the pegs, then dropping the ring sometimes. And the scope and instrument is going out of the view of the workspace. And they are also doing the tugging of the rings, multiple attempts to pick. So this is a novice. You can see jerky movements, tugging the ring, sometimes hitting the activity plate and multiple attempts. And sometimes they drop the ring. So all these parameters are negative scoring. We give them score that he moved out of the view of the complete simulator. He broke the ring. Now this is the first training module on which like 1 to 2 weeks they train to develop the basic psychomotor skills. Then there are other tasks involved in the endoscopy for which we have created other simulation models. So this is an endoscopic endonasal skull-based trainer in which we have introduced different activities. Like pick and place is there using these objects, then drilling is there, then incising on a rubberized platform, then precision movements around this. We have created a H and this S form of structures. So this work also has been patented. And this is an endoscopic third ventricular simulator, so which I showed you the animation of the surgical video. This is the simulator for that. So to reduce the cost of training multiple sessions, what we have done, we have created a bottle lifer structure. If you can see the second image, so they are small flap of different structures. So we are only printing those structures which are particularly being used in that procedure and replacing it. So the cost of each session becomes very less. Otherwise, if you completely print the complete simulator and use it one time, that will be very expensive. So this thing also we have received the Indian patent. And this is a navigation simulator. So navigation is a tool that surgeons use in the surgery routinely to localize their instrument tip. Like they have reached the tumor location known and how much tumor they have removed. So this is a simulator for that. And Indian patent has been applied for this model also. And this is the epidural simulator, in which basically they have to pass a big spinal needle into the epidural space and give the medication for different procedures. And again, we use the CT scan data, segmented different layers, and use the multi-material digital anatomy printing. And there is a sensation of pop when they insert that particular region while passing through the ligamentum flammum, and we are able to achieve that. And this model is also printed using the DAP. Now coming to the surgical skills evaluation. Now what happens if we give the training to surgeons and blindly they're coming and practicing, they don't get any feedback that how good they are. So we are working a lot on the skills evaluation also, and we are using different type of electronic sensors. We are placing sensors on the instruments to calculate how much forces they are applying for the cutting task. And so we conducted a study to find what is the optimal sensor placement site. So we place sensor on the upper arm, forearm, the wrist, on the forehead also, and the surgeons did the training and they provided their feedback that which is the location they are most comfortable. So if you see the results, we were getting the more accurate results on the dominant wrist and the non-dominant wrist. However, this site was not optimal as per the surgeons, since they said that we are getting disruption while doing the procedure. So what we decided that we will be placing the sensor on the forearm, which is a site which is not causing any interference to the procedure. And we created this 4 myography band in which we placed 8 FSR sensor and an accelerometer, which can be wrapped around surgeon's arms while doing the surgical activity, and we can capture the data. of the force or the kinematic movements, and then using the artificial intelligence, we can train our algorithm and give them scores. So as you can see, this is the training setup. So this surgeon is practicing the craniotomy procedure on the simulator that we have developed. So he is making the burrows, and this is the high-speed drilling station. And they are doing the drilling using an operating microscope. And you can see he's wearing that band that we have developed. And while he is doing the activity, we are getting all the data, how he is performing. And data is being captured in a computer, which will be later used for the analysis. So we are getting 9 channels of data, 8 FSR sensors, and then the accelerometer data is there. So these are the results. So we were able to achieve highest maximum accuracy of classifying the skills using the naive-based classifier. And we are also working on the surgical planning, which is basically the process before doing the surgery, how to plan a surgical procedure. And we do planning for the complex surgical procedures, like these are the 2 cases that I can show you. The first one is a giant multi-compartmental skull-based chondrocarcinoma. So you can see this yellow-colored thing is the tumor, which is pushing the carotid arteries. So this we segmented, and we 3D printed the arteries and the tumor, and surgeons planned the surgery. And the next one is a giant aneurysm, which is very big aneurysm, which was pushing the carotid arteries and blood supply to the brain. And these 2 studies we planned using the 3D printing, and study was published in the Operative Neurosurgery Journal. And we are also working on the instrumentation part, and for this we are using the metal 3D printing. So what happened, the traditional instruments, so you can see these are the microneurosurgical instruments, these are the endoscopy instruments. But as we advance in the field using the endoscopical procedure or microscopical procedures, there is a very constrained operative area in which they are doing, and these are all straight instruments. But surgeons require additional degrees of freedom at the end effector so that they can move in different directions. So we created a repository of the existing instruments using 3D scanning. Then we did a study in which we printed a traditional instrument using 3D printing, that is direct metal, sintering stainless steel material, and we compared this with the commercial instrument. And the results were that the applied force for tip matching was higher in the control instrument, and the surface roughness was not that good. So it requires post-processing, in which polishing we can improve the surface roughness. And by this study, we found that, yes, 3D printed instruments can be used for the development of new surgical instruments. And this is the 3D printed ergonomic micro forceps we developed. So what was happening, when they were working on the high magnification, the tips were going out of view. So what we created a bayonet shaped at the tip of the instrument so that the instrument is always in the view, as you can see from this video. So that is a traditional instrument, and this is the new design in the bayonet shape. So as we keep on increasing the magnification of the microscope, this is 4x magnification, then 7x. So it goes up to 17x. So at 17x, what was happening, the jaws of the instrument, only one jaw was visible, and they have to hold the suture. So it was causing difficulty. So we modified this design, and the study was published in the World Neurosurgery Journal. And this instrument, we have transferred this technology to AVM Healthcare for the commercialization. So there is a need to augment the instrumentation also, with the augmentation in the optics in the. And this is another design which we created, the palm grasping based handle. So what was happening, the surgeons were saying that for the long surgeries, they were getting the fatigue on the hand because the traditional handle is having a ring type of structure. So they were having fatigue and the pain sensation at the particular pinpoints which were in contact with the instrument. So we created this ergonomic handle, and which can be used for the longer durations without any fatigue to the surgeon's hand. And this study was published in Neurology India Journal. And these are the results on the simulator. And we are also working on the robotic instruments. So we have created this design which is based on the spine-based. Just like the spine, there are discs in between which allow our movement in the different directions. We have created this manipulated design where a soft disc and hard disc are there, and it can rotate the end effector in different directions. This is another manipulated design based on a hinge joint, and you can see it is giving more flexibility at the tip. It can completely bend. So the bending depends on number of elements. The more the number of elements, more bending can be achieved. And this is a multifunctional instrument. Initially, we 3D print using the plastic, and final design is made using the metal. And this is the end effector that is fabricated using titanium material. So as you can see, the first one is machining, and you can see we don't get that good outcome, but in 3D printing, it is just giving the same thing as the CAD model. And this is also an interesting study that we did during the COVID. So what happened in the COVID, there was guidance that the surgeon should wear the protective eye gear while doing the surgeries. Now what was happening while they were wearing the protective gear, they were not able to focus on the operating microscope because their eyes and the distance between the microscope eyepiece lens increased. And as you can see, there are studies in which they told that the FOV was 31.6%, and using large goggles, it was only 75.7% reduction in the FOV. And by face shield, there was 61.9% reduction. So what we did, we scanned the face of the surgeons in our lab, and we created their surgeon-specific eye gear. As you can see, it has provision for the insertion of eyepiece, and using this, you can see there was only 10% reduction in the FOV. So this was used during the surgeries in the COVID period, and this study is also published in the Bioengineering Journal. Now to conclude my presentation, 3D printing has seen spectacular progress in the recent years for healthcare applications, and it was found to be an effective method for prototype development for biomedical application. It allows fabrication of patient-specific models and novel surgical instrument prototypes, and there is a need to steadily expand the 3D printing capabilities in terms of material properties and affordability. These are some of the awards that we received. The most recent being the Modi Prix Galleon Award. These are the patents and our publications, the conference proceedings. Thank you. So any questions? Yeah. Yeah. Hello. It is not affordable, I would say. That's why we are creating those type of models in which we can replace that small flaps for the iterations that we have to do. So it is not affordable, it is expensive. If we create the complete model for every surgery, the material cost is high right now. So, sorry, so the new endoscopy? No. It is not available commercially, yeah. Yeah, in the research phase only, yeah.
Good afternoon, sir. My name is Prathamesh Goswami. I know you did not talk much about this topic, but I, being a student of biomedical engineering, would love to ask you this question. What is the future scope of tissue engineering in India using bioprinters? Mm-hmm. Is it really far behind from other countries like the US and the UK? And how far is India from engineering a soft organ for an implant, also keeping in mind all the legal and ethical issues?
So the implants, it is very standardized right now. So there are standard guidelines, like there are companies which are giving materials which are already medical grade. So implants, it is very standard procedure, and routinely I have seen many people are using it, in which they take the data of the patient, they create patient-specific implant, and that is being put in the patient, and it is not very far. It is currently being used at many places. And when you talk about the tissue engineering, it is still in the research phase, not in India, everywhere in the world. So there is no right now product which is like you can 3D print the organ and implant it. So right now it is not like that the India is working somewhere. Everything is going simultaneously, since all the companies which are working on, they are at global scale. So I don't think there is some comparison where India is there and where the world is there. We are at the same pace where other people are working.
Are there any worth mentioning researches going on at AIIMS and IIT?
Yeah, research is going everywhere. But as I already tell you, tissue engineering is still a thing which will come in the future. Right now, there is not there. But if you talk about the bony implants, like the bone plate or the hip joint, that is already being standardized, and that is being used everywhere.
Okay, sir. Thank you.
Thank you.
Thank you, sir, for demonstrating different 3D printing applications in medical sector. Now I am privileged to introduce Dr. Dinesh Singh Thakur. Sir holds PhD in Mechanical Engineering from IIT Madras, currently serving as Professor and Director, Policy and Planning at Defence Institute of Advanced Technology, DRDO Ministry of Defence, Pune. Sir is a recipient of National Award for Innovative Research from IST New Delhi and recipient of Teacher of the Year Award of DIET Pune. Sir has nominated for Best Paper Award at World Congress on Engineering 2009, London. Sir had chaired for International Conference AES 2012, Italy. Sir has 105 invited talks delivered at various institutes, 20 STTPs, workshops, seminars Sir has conducted. Sir had chaired international conferences, India and abroad, more than 20. Sir has published 235 publications, international journals and international conference. Sir has many more contributions under his name. Sir has research interest in CAD, CAM, robotics, additive manufacturing, 3D printing, fabrication, characterization and processing of composite materials. With this brief introduction, I call upon Dr. Dinesh Singh Thakur to brief about applications of 3D printing technology in defense.
Do we have the caller mic? Do you have the caller mic?
Yes, yes.
Slide.
So this is the slide change.
This one?
Yes, sir.
Yeah. Thank you. Am I audible? Hello? Am I audible? Oh yeah, very good morning, or rather I should say it's a good afternoon. My presentation is slightly offset. The very reason is that I belong to defense fraternity. And with your permission, sir, I'm not standing over here as an expert like Rajiv sir, Singh Saab, and other dignitaries who are present on the dais. I'm standing before you as a senior student. Like you and me, I'm not an expert, I'm a student. The reason is that I always love to be a student throughout my life. There is a reason. The reason is that I love the definition of the student. When I learned that beautiful definition of the student, I started calling myself as a student. I would like to call myself as a student throughout my life. What is that definition of the student? They are the innocent human beings on this earth. Please listen to me. They are the innocent human beings on this earth who always answer in 2 words, pata nahi. Thank you. With these kind words, I'm starting my presentation before you. If at all you ask me the question the way the dignitaries answered, I'll be telling that you didn't listen to my talk, that I told you that I'm a student, and my answer is pata nahi. Thank you very much. With this note, let me start my presentation with this particular classic note. I know it is a lunchtime, but I'll be giving you a small classic snack of a technical content over here and standing before you. It's very important to know we need to change our life, right? When you want to change the life, you need to change the perspective. This is what generally, this is my signature slide where I start my presentation, any presentation across India or across globe. Change your perspective and you can change your life. Today, we are coming across most of the negativities, and after post-COVID, we know that the level of negativity which is riding our own mind. So the first thing which comes to generally as a human being, as Indians very typically, we generally say, just do nothing, have fun. The another negativity generally comes if at all somebody forces us to do is that, and immediately we answer to the bosses, it is impossible, right? It's not possible. One such technology is nothing but the additive manufacturing which evolved when it was coined first time, and the first answer came like it is impossible. The way the tissue engineering you are talking today,
Some of the people, they say it's impossible, but today that is turning out to be. Where exactly we need to look into. Please understand, though we have studied the mathematics right from our childhood, and we know that -3, -5, if I ask you, definitely you will laugh at me. If anybody will tell you that, okay, it's nothing but -3, -5 is equal to -8. When you know the mathematics is the negativity when you are adding up, why don't you add these two negative windows together, and it turns out to be this classic statement, just do it, nothing is impossible. This additive technology is such kind of a technology which tells you that today nothing is impossible. Everything is possible. So with this particular positive note, let me take you to the further. As I told you that I'm slightly offset personality on this dais. I belong to the defense. This is the classic statement which we need to follow because we are surrounded by the enemies, two big enemies, right? So this is where, as a India and even the government of India is emphasizing a lot onto the defense sector. What keeps me awake at night is, are we going to miss the next big technological advance, and perhaps an enemy will have that. And today we are witnessing every day now and then the way our neighbors, enemy neighbors are progressing. So it's a high time to come back from the technological point of view and answer what they have. We should not say that we don't have. Look into this particular perspective. Let me take you to this engineering. When I say the engineering, I'm not relating to any particular field. It's additive manufacturing. Time has come. Right from the morning, you are listening to NEP 2020, which talks about multidisciplinary, interdisciplinary, which is again a classic example of additive manufacturing itself only. So time has come to understand this particular aspect from the engineering perspective, from the medical perspective. Rajiv sir, in one of his slides, he said, use the word jugaad, which has become a Oxford dictionary. Slightly, I have got a different say on that particular jugaad. In a conventional local language, we call jugaad as a copying, nakal marna. But I have got my own say, and I always emphasize on that one, nakal marne ke liye bhi akal hoti hai. Right? So with this particular note, what we are seeing in and around, why can't we put our brain into that one? But you have to have one capability with respect with you that's called as Apple's quotation, think differently. So you need to look into the things which are happening in and around from a different perspective. Definitely you will be able to excel in your life, and that is where we Indians need to appreciate that. Why am I saying so? There is a reason. If you happen to see this classic data which is published across the globe, and even the industry people are here, they'll appreciate that. An estimated 75% of the new product fail. It's not my data, it is a global data. An estimated 46% of the resources that companies devote to the conception, development, and launch of a new products go to the venture that do not succeed. It's a fact and figure. Raju sir can correct me because he's from the industry and he knows this data, and industry people are sitting just before me also. Now, where exactly the things are going wrong? Why we need to look into this particular technology of additive manufacturing to convert this particular data into the reality? Why am I saying I'm living in a democratic nation where 51% carries the majority? So let's appreciate that. Where exactly we need to look into that one? And if you look at from the industry perspective, everybody knows this classic chart. Some people, they were using right from the beginning a classic word, conceptualization. And if you look into the cost, it's at the design stage itself only. That is the reason I was emphasizing a lot onto the design stage itself only, where we need to have a capability of thinking differently, where you can bring down the cost by 70% itself only. And the classic example of Singh Sahab, which he demonstrated through the medical instruments and etc. And the way madam asked, is it affordable? This technology is the answer which makes everything affordable, right? Now let's understand from this particular one. Why am I quoting so? I'm quoting this particular gentleman, Nobel laureate statement because we have got 140 crore janta, and that is what we have the capability. So we haven't the money, so we have got to think. That is the reason, the second point I'm telling you that, think differently and you need to think. That is what I'm trying to correlate. Again, I'm doing an additive manufacturing of the thought process which are given by the different people, experts. So understand, why am I saying so? Somewhere, most of the platforms you might have heard so many experts, we missed the bus. The missing the bus started from the 1960 when whole world was talking about globalization, and unfortunately in India we started talking in 90s. That is the region where we missed the bus. Now it is a high time. I'm talking to the young minds sitting before me. My talk is not for the people who are sitting on the dais. My talk is for the young people sitting who are across me, so who needs to think differently and contribute in this era where the government of India is talking about vocal for local and make in India concept, because we have got a brain power. Now, when I'm talking with respect to this, some of the people, they said that, okay, now somewhere we are not able to invest. R&D, Raju sir, 0.7. Why? The unfortunate part is that, unfortunately, we are not trying to understand the science behind the technology. Now, the time has come to understand as an engineering student. Most of the times we used to say we are the engineers and we are applied researchers. Why should I talk about the science? I'm an end user. Gone are the days. That is the reason after 30 odd years, the education policy got reformed and saying that understand the scientific behavior behind that one, you can develop the technology. Again, additive manufacturing. You need to blend it additive. You need to do it so blending properly so that you will be able to appreciate this statement, what is called as today's science is tomorrow's technology. That is the reason this 0.7 will be getting increased like anything. But unfortunately, we are not emphasizing to understand the science behind that one. Now, design thinking is another concept which we are talking about. But most of the times we are talking through the podiums only. Now, time has come to apply it. In an Indian context, unfortunately, we are not applying it. No, you have to apply it. It should not be only from the talk point of view. You need to demonstrate. Singh Saab, the way you contributed into the medical field, developing the so many fantastic instruments, hats off to him, right? So now when we are talking with respect to this, this is what we need to appreciate. Design should be manufacturable. Earlier, the design and the manufacturing people used to talk at a two different poles. They never used to talk. Even it happened with the DRDO, sir. Let me tell you very honestly. DRDO is I belong to the DRDO fraternity, defense fraternity. R&D, research and development, and the ordnance factory they used to convert. To your surprise, we never used to talk to each other. But time has come. Today, if we are coming out of our comfort zone, we are going on to even the border area to understand the environmental condition so that our weapon should work effectively. Because no longer we are sitting into the air conditioners and etc. Now that is the reason, unless and until, because a typical mechanical engineer always say, seeing is believing, that we are implementing into the defense sector. And today, you know, we are exporting our defense equipment. I need not to, comment on that one if it's available in the open domain. Was it the scenario? It wasn't a scenario. But it is turning out to be. DRDO used to get criticized like anything, but getting appreciation one after the another. Because there we are using this technology of additive manufacturing itself only. Another classic example. Make the things right the first time itself only, which was never used to happen. We used to rework the systems. No. You have to think. That is the reason, understand my first slide, 70% cost. Whatever you do in the design conceptual stage, there should not be rework. There should not be any rejection in the era of PPM, parts per million. And that is the reason. What is the answer to this one? To achieve this, what is the solution? Additive manufacturing. That is the reason we people are sitting across your ear and listening right from the expert morning, all the experts. Now let's understand. There's one more important area which we need to appreciate. That's the reason I told you that I have come here to add up a different, you have heard statuses, they say that they want to be the pioneer into the polymer. You have seen Singh Saab metal. Why can't we marry this polymer and metal in a fantastic fashion by additive manufacturing? You can yield the benefits of the metal and the polymer together. That's the reason that area is called as a composite material itself only, where we are trying to marry the metals and the polymers together and then trying to yield the benefits out of it. Unfortunately, we don't talk. We Indians don't talk to each other. We hide the information. We hide the knowledge. No, additive manufacturing doesn't allow you to do that. Appreciate that. That's the reason you can see that if you look into this one, today, everybody is talking about strength to weight ratio in aerospace industry. You talk of anything, human being, size 0, isn't it? So that is the reason where we have to understand two concept point of view. One is called as a specific strength and specific stiffness. You see, sir, U. Chandrasekhar, my former colleague, right? He showed you one classic Ashby's diagram. What it tells you that how to make use of that Ashby's diagram from the specific strength and specific stiffness point of view. The answer lies over here, this composite material. Now, when you're looking to this one, again, aerospace industry, you can see the classic example of Boeing 787's Dreamliner, where they have used a 50% of composite. It's a classic airline. One should fly by this particular. You will go mad. I flew. That's the reason I'm telling you. Now, why I'm saying so? There is a reason. Just because you have got a material doesn't mean that you can convert into the reality. Design should be manufacturable. Don't ignore this particular statement. What does it mean? Then you need to find out some kind of a techniques to convert this particular material into the reality. The answer lies the additive manufacturing, 3D printing itself only. So this 3D printing is a renowned, recognized as a manufacturing techniques that will revolutionize the whole product design cycle itself, and that's you are witnessing now and then. Having said so, let's try to appreciate, and as I told you that, these are the two classic diagrams we used to study at a different level, isolation. Now, if you combine it, whatever the benefits you have, the first diagram and the second diagram, you will be able to yield it. And that is what we try to do in the design aspect from the defense applications point of view. This is another classic example like Ashby's diagram, where you can see that conventionally what we used to do, if you do it by additive manufacturing, there is a lot of cost saving, what we call it as a sustainability. And India is looking from the sustainability point of view itself only. This is what is something, a sponsored project worth of 1 crore rupees, which we work for one fighter aircraft. I'm not going to name that aircraft, or a future aircraft, which again, I'm not going to tell you the name, but I'm going to tell you that what exactly we did. Because we wanted to replace good number of metallic parts and etc. Right? Do you think that it's like going to the grocery shop and asking for something? No, it's not that way, which you can witness over here. As FDM technique, Stratasys is the pioneer. I need not to talk about them because they are the people, authority people to talk about in all these FDM techniques and etc. Another example. Who is a good engineer? A good engineer and one who makes use of the available resources. I am of that saving. These are the low-cost FDM printers available across the globe. Low cost. Why am I saying low cost? Because I want to yield the low cost. I want to use the mechanism which is available at the low cost for my high-end application sort of thing. So we use the FDM techniques for the low-end application sort of things for a high-end utility from the defense point of view. This is the printer, thanks to Stratasys. What we got it, the answer, right? We were working on to our experimental basis and etc. By that time, they introduced this particular printer into the market. We bought it. It's an affordable cost. And then we started playing around and we did some modifications and we yielded with a fantastic, outcome from this particular printer itself only. I'll not be taking into the much of the detailing because what beautiful aspect this particular printer has got. Right? When you're looking to this one as a typical engineer, as the Singh Saab showed you some kind of a publication through that you need to establish across the globe. So we did the permutation and combination. We applied our brain differently and we got into some kind of a analysis. Again, today, another branch which is coming in a big way that is called as a nature-inspired design. You need to look into the nature so closely, it teaches you so many things. We started looking at the turtle. If you happen to see the turtle shape, and if you take a cross-section of that, the kind of a structure, we evaluated, and we got to know that, it has got a fantastic features. And if you could mimic that, then it can be used as a armor protection system itself only. So we got into that one, and we started using this particular printer, low-cost printer, and then we got a fantastic results and etc. So like this one, we worked on that one. I'm just flashing the result so that I'm giving you the proof. It is not that I'm giving you only a theoretical talk. Practical also, we validated all those aspects and etc. We did all those impact analysis and etc. because when you are talking of armor protections and etc., you need to see that what is the impact analysis of that one. This is what some kind of analysis what we did because I know it's a lunch time. So I don't want to get into barge into much of my time into the lunch time itself only. And then that is how I told you that we varied the different variations, orientations, their laminate structuring and all those kind of thing. And you can see that, now finally we honed down to the final analysis that is called as a drop impact. Because when you are firing a bullet or a bird hitting to the aircraft, you know what level of problems they are creating. That is the reason we worked on to some kind of an impact analysis. We got a fantastic result. And then those fantastic results at the end of the day, unless until you publish and showcase internationally and they accept, it doesn't get validated. We did that. One of my PhD students worked on that one, and you can see what benefits we got out of it. I don't want to comment on that one, much on that one, but just I would like to flash these journal papers. Today, he's working with one of the very high-end kind of a university in Luxembourg, my PhD student, having a fantastic, attested 6 papers, and a record time he completed his PhD. Why am I motivating you? Don't think that, okay, you can complete the PhD in 5 years and 6 years. He completed in 2 years, 9 months, and that too with a high-end kind of publication, and today he is pursuing his postdoc in Luxembourg. Most of students are pursuing their postdoc or their faculty into the foreign. Why am I saying so? The reason is that most of the people, we get scared doing PhD or research. But if you do the research fantastically by applying a think differently concept, the outcome is before you. At the same time, from the industry point of view, because industry experts are sitting over here, every time they're talking of minimizing the waste, right? And the lean manufacturing, one such concept. Now, to prove this, my statement, we generally look at this half-filled glass with the 2 aspects. A pessimistic say half empty, optimistic say half full. But a lean manufacturer says, can I reduce the glass by half the size? Why am I quoting this particular slogan? The additive manufacturing reduces the number of parts, the way you showcased in the instrumentations and the Honda Amaze, examples. Not only that, it reduces the weight, it reduces the number of parts and etc. The assembly time gets increased. That is the beauty of this particular additive manufacturing and etc. So with this note, I'm just concluding over here. I know different specialization people are sitting. Those who are sitting, nobody spoke about the electronics industry point of view. The last statement is for the electronics people. Nowadays, we are working on that, those aspects also. Additive manufacturing is the solution where you take a lot of time to embed all those kind of a copper wires and etc. That can be done by this using this particular additive manufacturing technique. Thanks for your patience hearing. Thank you very much. I'm concluding my talk. Thank you very much. Thanks. Sorry.
Thank you, sir, for giving us various 3D printing applications in defense sector. Now I am delighted to introduce Mr. Erez Benzivi, Vice President, Head of Stratasys Medical, Israel. Sir holds BTech degree in Industrial Engineering from Schenker College of Engineering and Design. He has pursued MBA from Bar-Ilan University, Israel. Sir has 15 years of leadership experience developing rapid growth strategies for medical device companies. Before joining Stratasys, Sir worked in senior role at various companies leading products from inception to commercialization. Among many companies, Sir was General Manager of Integrity Applications, NASDAQ Limited startup company, developing a non-invasive glucose monitoring device for people with diabetes. Sir worked 6 years at 3D System Healthcare in various roles, including as a head of the global market development for POC solutions, overseeing global market development and expansions. With this brief introduction, I request Mr. Erez Benzivi to demonstrate J850 digital anatomy printer key features and its capabilities. Sir has joined us online.
Yes. Good afternoon, everyone. Hello, everyone. My name is Erez Benzivi. It is a great pleasure to attend the event today and take part of it. And in the next 25 to 30 minutes, I would like to take you through the future of 3D printing and touch upon some of the use cases in the medical field with emphasis on the J850 digital anatomy printer and the use cases in various domains. So I'll start by meet Alon. The year is 2012. Alon is an 18-month-old, is an active boy, normally liked to play with the ball with his grandmother at the backyard, and like every other day, he was playing at the backyard in the back of the garden. wrong movement with his leg, he twisted his leg, and this resulted in a spiral fracture in his left femur bone. For those of you who are not familiar with the human anatomy, the femur bone is the largest bone in the body, and such fracture is a dangerous situation, especially when it comes to infants like Alon at his age. So Alon's parents are rushing now to the hospital, and in consultation with the medical staff and the orthopedics, they decided to put Alon in a full body cast for 6 weeks. So my very happy and vital boy that was just learned how to walk, now he's completely paralyzed with this full body cast. The casting is heavy. His mother and grandmother could barely lift him up and pick him from one place to another. There is a challenge to exchange diapers. He cannot take any showers. And add to that this is August in Israel. That is the hottest month of the year. So taking him outside is subject to him being sweating, and this will end up by itching, and a very unpleasant and inconvenient situation for both the boy and his family by all means. Fast forward today. This is how these fractures are being treated at the point of care with the help of additive manufacturing. Aesthetic, lightweight, removable, can be washed, no challenge with diapers. If you were asked the boy's parents 12 years ago, would they have paid out of pocket to get this treatment to their boys? I can bet and guarantee that they would pay a fair amount of money just to get this for their boy. Now, this is not the only patient-specific solution that are provided today at the point of care. And actually, additive manufacturing solutions are leading the personalized treatment and patient care revolution at point of care. We're seeing this with orthotics and prosthetics, with anatomical models that are used for preoperative surgical planning and also for diagnostic use. We see these with surgical cutting guides and drill guides that are tailored to specific pathology. And we also see this with patient-specific implants, like the cranial implants in this image. And last but not least is the beginning and the research around the regenerative medicine and the bioprinting, which by all means, we are just scratching the tip of the iceberg here. Now, we need to remember, it's not all about the 3D printer nor the material. We are talking about a full digital workflow that is aimed at design and fabrication of a bespoke solution, what we call the digital thread. It starts by patient imaging, that is a CT or an MR, using a special software to convert these images into a patient-specific anatomy that now can be either printed, be used for planning of the right surgery approach, or being used to plan and design a tailored instrument, or a tailored, whether that is a cutting guide or a tailored implant that is used to fit the exact hole or fill the gap that was now resected from the human anatomy. So all in all, we are looking at a full digital workflow that encompasses materials, software, and as well the printer itself. And here is where Stratasys Medicals comes. Our vision is to transform lives through personalized and scale additive manufacturing solutions. And our mission, our road to our mission is really to help caregivers and manufacturers improve the way patient care and treatment are given around the world using additive manufacturing as a standard of care. Now, the medical applications are among the fastest growing segments in this additive manufacturing sector. You look on the right side, the global additive manufacturing device market is growing in a very rapid pace from $3.2 billion market in 2022, expected to reach almost to $8 billion market by 2030. And there are a number of drivers that are associated and driving this trend. Primarily, we're looking at rising prevalence of surgical procedures and a growing demand for quality healthcare, advancement in imaging technologies, new treatment options where additive manufacturing is a critical role in spearheading this revolution. We also see medical device manufacturers that are rising their exponentials on R&D and building production capabilities for customized solutions They're building this in-house, where previously that was the realm of a service bureaus or contract manufacturing organization that providing these services for them. We see growing demand for fast turnaround time, overcoming supply chain challenges, and we also see governments incentivizing manufacturers towards building their manufacturing floor locally. Faster turnaround time, overcoming supply chain challenges, and giving the solution as fast as possible to the healthcare providers. So now we ask, why 3D printing? Why anatomical models and instruments in medicine at all? The mission primarily, or the target audience, are always the patients. We are all surrounding patients. It's all for the patient's benefits. Whether it's a better outcome, shorter recovery time, being able to consent the patients and educate the patient about the upcoming procedure, avoiding anxiety of the patients. That's all being treated through additive manufacturing and tangible tools that are providing with this technology. For the healthcare providers, for the healthcare practitioners, they are able to deliver higher accuracy and better treatment options, minimizing risks, anticipating complications, preparing better for the upcoming surgeries, being able to educate themselves better through more training capabilities, better training tools, through research and education institution training, and also at the OEM side, greater freedom of design and development, bringing faster time to market, new medical devices, new techniques, new treatment options. And finally, this is all comes to reduction in cost, where the procedure and the processes becomes more efficient. You are shortening OR time, you are shortening the procedure time. This pays for the hospitals and also for the payers. So there are a growing range of additive manufacturing uses that are aimed at different audience and different level of expertise. We are looking at the engineering sides, which you're all familiar with, the ability to prepare tailored rapid prototyping, tooling, jigs and fixtures, and we just spoke about the expenditures that medical device manufacturers are putting into the R&D. On the right side, this is a combination of both design and engineering and manufacturing skills that are associated with the creation of either patient-specific anatomic models aimed at point of care, device manufacturers, and even research and education, building solutions that are aimed at additive manufacturing through end-use parts design, and also continually exploring more tailored solutions, patient-specific advanced solutions to address the growing demand for these personalized therapies with the advancement in technologies, imaging, and new techniques coming soon. Now, in this presentation, moving forward, I won't be able to touch upon all these technologies and all the use cases, but I would like to take you through the digital anatomy printer and how this is paid with anatomical and tied to the anatomical model world. I'll start with the J digital anatomy printer, and basically the PolyJet digital anatomy printer was started by the platform that was enabling using or talking the terminology of colors and multiple materials. The combination of various colors and materials allowed for the creation of exact or accurate visualization of the anatomy with combinations of different materials. In speaking with the medical industry and also with care providers, we've been asked and challenged, what about adding the functionality feature to the appearance and the shape of the model? And there we came with a new technology that allows now to switch the terminology from talking colors to talking mechanical behavior that follow the human anatomy. Talking about flesh, fat, bone, tissue, or skin, combining everything in one pot and allowing unlimited configurations of different behaviors with additional presets of specific mechanical properties, this to bring the exact functionalities that replicating not only the shape, but also the tactile sensation of the target anatomy. In order to bring it into the market, we had to go through rigorous and extensive validations. And among many, we had to show that the mechanical properties are behaving exactly as with human anatomy. In this case, I will share a few examples how we were testing this. Here we were testing a synthetic tissue. We were testing the combination of the materials that they can replicate a porcine tissue. In this case, the stiffness on the left side, these were the results that were generated by the J5 DAP and the J850 DAP. And you can see that not only that the range is very small, showing that the repeatability of the results are significant and they are very favorable versus the porcine anatomy. But you can also witness and see that the ability to simulate and combine the printer behavior, the printer materials, and replicate the exact range of behavior that is set by the human or by the porcine anatomy, there is almost one-to-one coverage by the range of the tissue stiffness of the porcine and the combination of materials on the left side. Testing the mechanical properties of the bone behavior. In this case, we were holding testing of pull-out force, torque insertion force, and also spine compression. And we were comparing the shear stress among many to the literature review. And the range that we have found that the combination of materials using the printer was covering the very same range that was set and found at the literature for human behavior as well. We also took it to the vasculature area. And here we also seen under a pulsatile closed circulation system, we were testing the contractility and expansion of different vessels, the aorta, the carotid, and the coronary. And also here you can see that the combination of the different materials fall within the range of the literature review that shows the distensibility of the vessels as well. So who are the target segments for the J850 or the J5 digital anatomy printer? We are looking at the point of care. They are using these anatomic models for enhanced surgical planning and diagnostic use. It allows the surgeons to improve their procedural efficacy and also the outcome of the surgery as well. And these models are helping doctors to bridge communication between the medical staff and also to bridge communication between the staff and the patients and the families. On the medical OEMs, these help them to accelerate product development and time to market. It assists them to drive adoptions of new technologies or new treatment options that they offer to the doctors and surgeons. And it also supports their ability to manufacture small and mid-sized batch production as well. On the education and research, this allows to enhance training of the next generations of doctors and also to support innovations of new exploration and new treatment solutions that are being tested and explored on every research institute almost on a daily basis. So I'll take you now into a few samples with lead applications today in 3D printing in medical. We can talk and see that there are many disciplines that are benefiting from the usage of anatomical models and more. The craniomaxillofacial and orthopedics disciplines are by far the most mature disciplines that are using today anatomic model and surgical guides. But not far behind, you can see anatomic models used for cardiovascular and neurosurgery, neurovascular surgery as well, radiation therapy with bolus treatment as well. And there are many other specialties that are following this, like vascular, ENT, simulation, and more. Here are a few examples of how the anatomical model printed with J850 digital anatomy printer are used at the point of care. In this case, this is a case from Seattle Children, a preoperative surgical planning of a slide tracheoplasty. This is treating an infant with right bronchial stenosis. It's a rare etiology of the respiratory distress in a neonate. The surgeons here, what they did, they took and print a numerous slide tracheoplasties ahead of time. And this allowed them really to practice a life-size model of the infant's airway and really practice and anticipate and assess the best treatment option for the toddler. And like Dr. Johnson mentioned at the end of this practice, the ability to hold the model in his hands and perform the actual procedure alongside his peers was allowed them critical discussions and learning at the place before the surgery takes place for the better outcome of the surgery. Here is another sample from Nicholas Children's Hospital. This is a rare congenital heart anomaly. It's a congenital defect, LVOT, left ventricle outflow tract lesion with a rupture of the sinus of valva salva to the left ventricle. This defect is, I'm not getting into the very medical, terminology here, but it's a very rare anomaly. It's a 13-year-old girl from Haiti. The challenge for the doctor was to reach to the ruptured area without altering the surrounding. And actually, they had to assess what is the best surgery approach that they should take. And they printed the anatomy of the patient, and they were able to cut and suture. And like Dr. Redmond Burke mentioned at the end, he said that he was able, and he actually changed his surgery approach only by practicing on the model. And I can only imagine what would have happened if he was taking, or if he wouldn't have the option to train himself or to practice ahead of the surgery. What would have been the results of the surgery, or what complications could occur if he was not avoided them. Here is another way of how 3D printing used at the point of care in the craniomaxillofacial. This is a tumor resection. And in this case, not only creating anatomic model for the better planning, in this case, they were also plan and design a surgical cutting guides that help them to execute the plan precisely at its most precision. Basically, they were able to design where to cut, where to drill, and how to harvest part of the bone from a different part of the body and fill it in the mandibular bone area where was taken out. In this case, the doctors were able to save up to 3 hours in surgery time. This is a huge saving for the hospital. It's a huge saving for the hospital. It's a cost reduction. And this is another benefit that the ecosystem that I just talked about benefits from this use of anatomic model and surgical guide. Another piece here, and I'm sorry for those who are sensitive to these images, coming from Hadassah and Karem Medical Center. And this is a reconstruction surgery in orthopedic as well. As you can see, not only the anatomic models were used, but in this case, the printed part was printed on an FDM technology with Ultium 1010, and it was used to precisely cut the portion that is missing to reconstruct the bone per the plan that was designed and agreed with the surgeons ahead of time. Taking the model into the medical OEMs. In this case, device manufacturers are using anatomic models with the digital anatomy printer to advance their surgical skills training, assisting in educating and introduction of new medical device and treatment as well. In this case, the ability to design and have a repeatable and accurate training model assists them really to replicate the technology and allows their surgeons, regardless their expertise, their expert level, it allows them to train and introduce new techniques in various different environment settings as well. The alternative is actually to go into cadavers or even with preclinical testing with animals. Cadavers and animals are not the same all the time. Each cadaver, each animal will anticipate different results. With the digital anatomy printer, with the models, you can actually have a repeatable results, and also the setting is easier. You can do it at trade shows, you can do it in your simulation center. It's less messy than using the other alternatives as mentioned. Here is another case where the 3D printing is used, in this case at the very beginning. This is with a Psyche Medical, and they were using the PolyJet technology in this case to prototype and assist in converting an idea into a product in a lightning speed time. So they were able in a number of weeks from idea into a product to get the product in hand, and later on to take it from that stage into clinical trial also by printing small batch production on the PolyJet technology. So their CEO was mentioning at that time, he was saying, don't think, simply print. That allows us to get our ideas in a tangible way in our hand and minimize any errors and speeding up our development process. Here is a combination of the use of both research and medical OEMs. And in this case, the challenge was to develop an advanced algorithm that is aimed at translating voxels, the pixels in the CT images, into exact imaging properties, radio opacity imaging properties of the human anatomy. This is a joint development that Stratasys is holding with Siemens Healthineers. And the end goal is the ability to have a lookup table and create phantoms that can be used to calibrate machines, phantoms that could address specific pathologies that is impossible to create in any other traditional manufacturing. And as you can see at the image on the right side, the right image is a phantom that was replicated from a real patient scan using radiomatrix technology that is running on the J850 digital anatomy printer. This is a unique technology, a unique behavior, and the ability to simulate almost one-to-one also the appearance under X-ray and CT is great. And I can guarantee that there are many things that we haven't unveiled yet, and there is more to learn here in this world as well. When we come to the research and education, as I mentioned, the rigorous testing that we were doing, here is another case where we were mimicking vasculature behavior. Again, the contractility and expansion, the ability to use gel matrix, that is a unique material that runs on the digital anatomy printer, the ability to develop and also print fine vasculature structures down to 1 millimeter in diameter and also up to 1.5 millimeter wall thickness. This was not possible before with any other technology, because the moment you tried to clean the support from the model, it was torn. So the ability to use gel matrix not only as a support, but also as a simulating material is great. And also to assist simulation centers and research and education to explore the behavior of different vasculature with the insertion of tools and deployment of stents and other implants into these models as well. Last is the research and education is another case here. In this case, we were training surgeons to improve their surgical skills. In this, we were replicating tissue behavior using the tissue matrix. Again, this is a soft, ultra soft materials that allows a very realistic tactile sensation and support fine structures such as the cardiac cords and also valve leaflets. In this case, these models were allowing the doctors to really train and practice their surgical skills in training environment, practicing the cutting, suturing, and device placement, and also patching skills with these tiny and fine-tuned models as well. So what the future holds for us? So we will continue to see an increased demand and prevalence for personalized therapies options with the advancement in imaging technologies and advancement in materials and automation of software. We at Stratasys will continue to strengthen our infrastructures, but also to support the technologies with materials and enabling software with automation to allow greater workflows with personalized solutions. We will also see by manufacturers shifting towards on-site manufacturing. We're already seeing this with point of care, insourcing many of these technologies and bringing this in-house. The ability to manufacture this in-house is tied to also rigorous quality focus and increased regulatory control, because we need to keep in mind that patient safety is our top priority. So once we become the manufacturer of these very delicate and complicated medical device manufacturers, we need to bear in mind that this should be adhered to compliance with quality and making sure that we have a unified approach to validate our outcome and not jeopardizing the safety and the health of our patients. And last but not least, the 3D bioprinting. The 3D printing, by definition, will continue to spearhead the regenerative medicine revolution. It is and will continue to play a major and critical pillar, a critical foundation in the revolution of regenerative medicine. And as my colleagues prior to my presentation said, we are at the research stage. There is much more to grow. We are not even scratching the tip of the iceberg with regenerative medicine, and there are more to come, I can guarantee. But all in all, we are very positive that the market is heading this direction, and in the future, regenerative medicine will be at a commercial level for sure. And with this, I would like to conclude my presentation. And by the way, if you were asking how is Alon today, 13 years after the event, Alon is a happy boy. He still likes to play with the ball. He barely remembers what happens to him 13 years ago. And I can guarantee to you that his mother and myself will never forget this episode because he is our beloved boy. I would like to thank you for listening and taking the time to listen to me. And with this, I will hand over to the respective committee. Thank you very much.
So much. Thank you so much. If audience like to ask some questions to the speaker. So we have a question for you from the audience.
Good afternoon, sir. I am from Mechanical Branch, second year. My question is, can we make an actual implant using 8J50 technology?
Okay, thank you for your question. Right now, the materials that are run on the J850 printer with the digital anatomy printer are not implantable. So the answer to your question, no, you can't create implantables with this printer.
Do we have any other question?
Good afternoon, sir. My question is that by using the CT scan data, can we make a life-size models by using the data in the CT scans?
Absolutely, yes. The answer to your question is yes. As I mentioned, the digital thread is having a CT scan, and with applicable software, you are able to convert this scan into a printable file. And this printable file is a life-size model that can be printed on this printer.
Thank you, sir.
Thank you so much. I once again thanks Mr. Erez for his time. Moving forward, now it is time for the presidential address. I request Honorable Vice Chancellor, MGM University, Professor Dr. Now I request Dr. Praveen Suryavanshi, Deputy Dean, MGM Medical College, to have a few words.
Good afternoon. All respected dignitaries on the dais, off the dais, all respected senior teachers and dear students. What I feel that technology is coming in a big way. I just narrate one story that we all of us know. It's one first part of it. It's a story of rabbit and turtle. That we know rabbit has the strength of speed, turtle has strength of endurance and stamina. So ultimately, in our routine story, turtle wins the race, but later on they become friends, and they decide that we should not fight with each other. We should make best use of our strength. So whenever there is a ground, the rabbit used to take turtle on his back, and they used to cover that long distance in a short time. And whenever there used to be any river, they had to cross. So that turtle used to take rabbit on his back, and they used to cross that river. So it is a symbiotic approaches between the technology and the science and the market. What it in the best interest of the community. So we had a session last week only in our IMA whether AI will replace medical professions. So same thing I said, whether it will replace or not, but if you don't adopt technology, the profession will not be replaced, but you as a person will be replaced. So it is the best time, whatever is there in the market, you must adopt in the best interest of our community so that we together grow in the interest of the community. And as rightly said by Dr. Thakur, that additive approach has to be there to make best use of everything, whether it's a human values or whether it's a technology. It should be in the interest of community. So with this few words, I really congratulate MGM University for getting best of best technology, not only for the teaching purpose, but for the in the interest of community. And I'm sure under umbrella of MGM University and MGM University of Health Sciences together will make best out of whatever we have in the campus. Thank you so much.
Thank you so much, sir. Now I request Honorable Vice Chancellor, MGM University, Professor Dr. Vilas Sabkar for Presidential Address.
Yes, on the occasion of inaugural ceremony of unique and advanced technology, anatomy 3D printing technology, we have heard a lot of experts. We have on our dais Honorable Chancellor, Sri Ankushravji Kadam, Dean of Medical College, Dr. Bora, Deputy Dean, Dr. Suryavanshi. From Israel, Mr. Ernst Benz, who talk about a lot of applications, Dr. Dinesh Singh Thakur from Defense Industry and Education, Dr. Ramdeep Singh from, of course, biomedical engineering expertise and coming from healthcare industry, Dr. Chandrasekhar, who was ex-DRDO expert, Dr. Rajiv Bajaj, who is Managing Director of Stratus India, and of course, as you know that our colleague, Dr. Ashish Gadekar, Registrar, Dr. Shinde sir, Dean, and ladies and gentlemen. As you know that in any educational field, research innovation comes together only through advanced technology. And when we integrate this advanced technology in education, of course, the quality improves, application improves, and which will give way to research. And of course, the research will finally land up into innovation and a new product. I could see here a lot of application areas that is nothing. The best printing and the technology is, of course, nature. Nature keeps on printing new products every time when there is revolution. And as you know that whether it is biomolecules or whether it is any technology, and when we derive this inspiration from nature printing is nothing but this technology. As we are coming to the era of frugal engineering and process optimization and intensification, we need to really make use of this technology in every possible field. And as you know that this is a true heterogeneous and multidisciplinary application of material science and engineering, biological sciences, computational skill, you name it, every technology has come together in order to make this 3D printing possible. So as you know that this goes with 3 dimensions, but of course there is nothing remaining that we can exactly produce the same product. Now we talk about the material to be printed, whether the whole house is getting printed, and to that level where you can also print using edible material, so that the cake is also getting printed, and of course a lot of application. So there is no limit for application of 3D printing to make more productivity as well as sustainability to conserve the nature. As you know that we are talking about energy conservation, we are also talking about the conservation of what you call nature. And that will be possible when we optimally utilize the technology. So this is the beginning, and at MGM University, we wish to integrate more and more technological what you call technology integrated education and research, which will give students new areas for not only research but also startup. So on this occasion, I congratulate everyone who has contributed for making this successful. Thank you so much.
Thank you so much, sir. Now to sum up the event with key takeaways and proposed vote of thanks, I call upon Mr. Pankaj Dhobre, Head IIRC.
Thank you so much. So, I, Pankaj Dhobre, on behalf of MGM University, Jawaharlal Nehru Engineering College, to have a privilege for vote of thanks at the end of inaugural ceremony of Stratasys J850 digital anatomy printer. So, the essence of all beautiful art is a gratitude. I truly express my sincere gratitude to Dr. U. Chandrasekhar sir, Mr. Erez Benzvi sir from Stratasys Israel, Dr. Ramandeep ji, Dr. Dinesh Singh Thakur sir, Mr. Raju Bajaj sir, and all delegates from Stratasys and Altem for accepting our invitation and taking out their precious time to attend today's inaugural ceremony. I take an opportunity to extend most sincere thanks to all doctors, engineers, industry persons who have come from different destinations and also have joined online for their support and cooperation. I would like to thank you, our Chancellor, MGM University, Honorable Shri Ankush Rao Kadam sir, for his continuous support, guidance, and encouragement to adopt emerging technologies to develop future-ready talent. I would like to thank you, Vice Chancellor sir, MGM University, Dr. Vilas Sapka sir, for his motivation and support to make this event happen. I thank Registrar MGM University, Dr. Ashish Gadekar sir, for his guidance of all our activities, ensuring that we always do the right thing at the right way. I am thankful Principal JNEC, Dr. Shinde sir, for his valuable guidance and support. I am also grateful to have Dr. Bora sir and Dr. Praveen sir for gracing this event. I am also extremely grateful to Dr. Geeta Latkar, Sudarshan Latkar, Deepika Latkar, who continuously supported us. I extend my gratitude for all head of the institutions, head of the departments, my colleague, faculty members, students from different domains and their parents. I am hopeful that the students and professionals from different domains, such as medicine, engineering, design, architecture, will utilize this facility for future research and innovation at MGM University. An event of magnitude cannot happen overnight, so it requires meticulous planning, execution, and bird-of-eye detail. We have fortunate enough to have backed by dedicated team of faculty members, especially Azhar Bargir sir, who for his equal contribution and efforts to make the success of this event, and my dear students, all who have worked hard to assure success of this event. So with this, I again congratulate all for the success of the event and formally declare the end of inaugural ceremony. Thank you so much. Have a nice day to all.
Now I request everyone to please stand up for the national anthem.
जनगण मन अधिनायक जय हे भारत
I request the students and volunteers to please stay back so that the dignitaries can leave the campus. I request the invited guest members, press, academia and industries to please join us for the lunch after the event.
बाहेरचं घ्यायचं का सर आपल्याकडे आहे ना